All right, please let's look up. We are going to look at absorption meter designs. Absorption meter designs. Now, we'll be looking at photometer, spectrometer, spectrophotometer, and colorimeter. Now, for the photometer, photo means what? Photo means what? And meter is used for measurement, right? Now, photometer is used to measure the intensity of light. Are we there? Photometer is an instrument that is used to measure the intensity of light. What does that mean? It's used to measure how bright a particular light is. So the photometer can be used to measure how bright a particular light is. Do you get that? So photometer is used to measure the brightness of light. That's simple put. Spectrometer. Have you heard of spectrum of light? Spectrum of light. Spectrum of light, we are looking at the different bands of light now. Now, spectrum of light, spectrometer, is used to measure what? In simple terms, is used to measure what? The different colors, right? Now, the spectrometer have the ability to separate light into their different colors. Like rainbow. Rainbow, you know, we have 7 colors of light, right? White colors. Red, orange, yellow, green, blue, indigo, violet, right? Those are the 7 colors. Now, this spectrometer can do that, can separate colors. Photometer, we are just looking at the brightness. Spectrometer can separate the colors, the light. So white light can be separated into different colors by spectrometer. Then spectrophotometer. Spectrophotometer now is a combination of spectrometer and photometer. So from the word you can see spectrophoto, spectrometer, photometer combined together. Now spectrometer separates light into their different components, right? Photometer measures the brightness, right? So spectrophotometer have the ability to separate light into their different colors, then measure the amount of each color of light. So spectrophotometer can separate light. So light is coming from here. It can separate it into their individual colors and tell you the amount of each color of light. Do you get? Because photometer is to tell us the amount of light, the brightness of light, how bright a light is. Spectrometer separates it into their different colors based on wavelength. Because yes, based on their wavelength, different colors of light have different wavelengths. If you are working in the lab with a spectrometer, we have what we call filter. Advanced, we use monochromator. Based on the color you want to check, if it is blue, blue have the wavelength it absorbs light best. Red has the color it absorbs, a wavelength it absorbs light best. So you always check. We have 520 nanometer, 320 like that, 720 like that, different wavelengths. If you go to the lab now, you see filter. It's a black substance, just short like this. Then there's a little hole here that have glass inside. Then by the side, you will not see, they will not write the wavelength, whether 520 nanometer, that's the wavelength, or 6, or they will write the wavelength by the side. So now depends on the color you want to analyze, you now select the wavelength suitable for that. Now, spectrometer have the ability to separate colors based on wavelength. Now, spectrophotometer is advanced in that you don't even have to be selecting, oh, this color is what I want to. You now pick the filter that have that wavelength. You pick the filter. Spectrophotometer is automatic. You don't use filter. It is inbuilt. Monochromator is inbuilt in the spectrophotometer. So the monochromator, what it does is it isolates the wavelength of the light coming in. If you look at this, let's use this to represent our spectrophotometer. We have a radiation source, a source of light. In the spectrophotometer, we have a monochromator that we isolate the light, the different lights based on their wavelengths. Now, as it isolates the light now, Monochromatic light is what is a monochromatic light? Light that have one particular wavelength, right? That is, you've separated the light into their components. So now it is only one spectrum of light that is passing through the sample. So the monochromator separates the light, isolates the light into their different components, allowing just one spectrum. Mono means one. Chroma is talking about color. But here we know we are separating the light based on their different colors. Now, it is one spectrum of light that will pass through the sample. And as the light passes through the sample, you agree with me, based on the Lambert's law, as the incident light hits this sample, some of the samples, they will absorb some of the light, right? While some will be transmitted, is it not? And the Lambert's law states that what? The amount of light absorbance is directly proportional to the what? Concentration and the what? Thickness, right? Or the path length. And is independent of the intensity of the light. Now, as this sample absorbs the light, we have a detector here to detect that the absorption. And then we have a readout device, a meter that will show the value of what you've done. Alright, so basically that's that. Now, colorimeter is more or less outdated. They still use it today. If you go to the lab there, you see it, colorimeter. Or this colorimeter, it still works based on this, but here you are using your eyes to compare the colors. You are using your eyes to compare the colors. So it works with eye comparison. In photometer and the rest, you don't use your eyes to compare the colors. But in colorimeter, you work with your senses. You use your eyes to compare the colors, the different colors. Do we get that? So photometer is used to check the brightness, the intensity of light, right? Spectrometer separates the light into their different spectrum, right? Spectrophotometer combines the two, so you can separate the light into their different spectrum and still measure their intensity. Colorimeter compares lights based on their colors with your naked eye. So you're using your eye to compare. Oh, this one is thicker than this one. This one is outdated. Alright, so we're going to look at, we'll still look at that in details. Alright, very quickly, let's look at the components of spectrophotometer. Now, the components of the spectrophotometer, we have the light source. And the light source, sometimes what they use is a tungsten lamp. But this tungsten lamp, do you know that filament they use in your normal light bulb is what? Tungsten filament, right? That's the light source we use here. But that light source, this tungsten lamp, is not always enough. It's not always sufficient to provide the ultraviolet rays of light we need. So sometimes we use the usual light used now for UV is either hydrogen lamp. You know, we have 3 isotopes of hydrogen, right? H1, H2, H3, right? Is it not? Yes. We have deuterium, we have tritium, right? We have the deuterium is heavy water. Now, we can use deuterium lamp as our source, or we can use mercury vapor lamp as our source of UV. So one component of the spectrophotometer here is a light source. And I've said we can use either deuterium lamp or hydrogen vapor lamp as our source, because tungsten lamp will not give us the sufficient UV we need. Monochromator here, we said the monochromator is used to do what? To isolate the wavelength of interest, right? So it's used to separate and isolate the wavelength we're interested in. Because spectrometric measures is specific for monochromatic light. That is, the light must be separated into their different components. And that's the function of the monochromator here. And different colors absorb light best at different wavelengths. We have our detectors. The detector measures the transmitted light, right? Now, the two types of detectors we can have is photovoltaic and photoconductive, right? The photovoltaic, we said it measures what? The flow of electrons, right? Flow of electrons from where? Flow of electron displaced by what? By absorption of electron. So as by absorption of what? Radiation. So as radiation, remember that you are putting your radiation now, you are directing it towards the sample, and some of the sample will absorb some of the radiation, right? And some will be displaced, is it not? This photovoltaic detector detects the displaced electrons after the radiation. So after you put the radiation source here, the displaced electron is what photovoltaic measures. Then photoconductive measures what? The charges, right? The charges at what point? So we are looking at conductivity here, charges conducted here. We are looking at electrons displaced. But basically, this detector is used to measure the displaced light. Basically, these are the things we have. We have a readout device. Readout device or the meter. This is like a screen that will display the amount. Remember, this can be used for quantitative analysis. So it can tell us the amount of that color present. Remember, we said spectrophotometer can separate light into their different colors and still measure the intensity, the amount of each colors present, right? So basically, the application of spectrophotometer is vast. First, we can use it to test for concentration, check for concentration, right? Because remember, from Beer-Lambert's law, absorption is directly proportional to concentration, right? So the more the substance absorbs light, the more it is in concentration, right? The higher concentration it is it not? So we can use spectrophotometer to test for what? Concentration. So it can be applied in checking the concentration of different substances. Also, it is used in the study of enzyme catalyzed reactions. It is used in the study of enzyme catalyzed reactions.